Ever wondered how industries measure the level of liquids or solids in their tanks without any physical contact? The secret lies in non-contacting radar level measurement. This ingenious technology, widely used across various industries, employs advanced radar techniques to accurately measure levels of substances without the need for direct contact, hence the term non-contacting. It's a game changer for sectors dealing with corrosive, sticky, and abrasive fluids, as well as for those handling liquids, sludges, slurries, and some solids. The two main modulation techniques that make this possible are the pulse radar technique and the frequency modulated continuous wave, or FMCW radar technique. Both methods use microwaves and time delays to calculate distances with precision. While they might sound complex, they are actually quite fascinating. So let's dive deeper into how these techniques work. The pulse radar technique is a marvel of modern technology. Let's dive into how it works. In its core, pulse radar operates by transmitting a microwave signal. This signal is then bounced off the surface of the product it's measuring and returned to the sensor. The magic happens when the transmitter measures the time delay between the transmitted and received echo signal. This time delay is used in a simple equation to calculate the distance to the liquid surface. The formula is as follows: distance equals the speed of light multiplied by the time delay divided by 2. Now, once the transmitter is programmed with the tank reference height, typically the bottom of the tank or chamber, the liquid level can be calculated. This is done by subtracting the calculated distance from the tank height. In essence, the pulse radar technique is a simple yet effective way to measure the level of liquids. The FMCW radar technique takes level measurement a notch higher. Unlike pulse radar, FMCW radar doesn't just send out a microwave signal. Instead, it emits a signal with continuously varying frequency. Picture a wave, constantly changing in its frequency, traveling down towards a liquid surface. After it bounces back to the antenna, it's mixed with the signal that's being transmitted at that time. Now, here's where it gets interesting. The difference in frequency between the received and transmitted signal is directly proportional to the distance to the liquid. It's a bit like tuning a radio. If you know the station's frequency, you can find it easily on your dial. FMCW radar works in a similar way, but instead of finding a radio station, it's measuring the distance to a liquid surface with high precision. The FMCW radar technique yields highly precise measurements, making it a reliable choice for industries. Non-contacting radar level measurement comes with its set of advantages and limitations. On the upside, it offers top-down direct measurement and can handle liquids, sludges, slurries, and even some solids. It's also insusceptible to changes in density, dielectric or conductivity of the fluid, and pressure, temperature, or vapor space conditions don't impact its accuracy. Plus, with no moving parts, maintenance is minimal. Even better, these devices can be isolated from the process using barriers like PTFE seals or valves, making them excellent choices for corrosive and dirty applications. However, a successful installation requires a clear, unobstructed view of the surface. Obstructions in the tank can cause false echoes, although most transmitters can ignore these. Agitation and the presence of foam can also impact the measurement, depending on the fluid properties and turbulence. Despite its limitations, non-contacting radar level measurement remains an invaluable tool in industries, thanks to its numerous advantages.